So in this video, I want to touch base for a design scenario that is utilizing floating static routes. Floating static is a great way of keeping a design simple, and if your goal is to really fail over when a link fails, if this link fails, you need to use the secondary address or secondary link or a backup link, then floating statics are good. Floating statics are really a default route that is two default routes, one going to the preferred one and then the second one is going to the backup one. Primary one is going to use a lower admin distance and the backup one is going to use a higher admin distance. Lower, higher. And I'll show you the routes, how that looks like in a VIOS. So this is your VIOS 3 as an edge router. Then you have a show IP route, which has got two default routes, one with the 10 admin and the other one is with 100. It's taking the first route as the next hop of 10.0.0.1, which is your ISP CE router, PE router, and then the second route is 20.0.0.2, which is your second ISP's PE router. And you want to design this so that if the link fails, it automatically fails over to the secondary link without getting into the fancy SD-WAN, IP/SLA design situations. To do that, if you put a switch in the middle with L2 links, the default floating static routes would not work. So let's demonstrate that, considering the fact that you have a switch in the middle. So you're actually plugging in your connections into a switch from ISP and your edge router, CE router to the switch and a PE router switch, just like how it is here. And one of your links goes down, doesn't matter. In this case, we're going to bring this link down and see how the failover works. So I'm going to bring this link down with the switch. I'm going to fail this guy, right? I'm going to disconnect this guy from this side. This is just a simulation. I don't have a switch in the middle, right? This is VirtualBox, not VirtualBox, VMware player, and just to simulate the real world scenario where the switch is plugged in. If this link goes down, your switch, the link on this side will not go down, and therefore your floating static will not work. And that's where you have to use advanced design like IP/SLA or SD-WAN kind of a feature set. But if you don't want to use that, you just want to use floating static and dynamically failover, you should not use a switch in the middle. Let's see how this works with the switch in the middle. Simulation again, I don't have a switch in the middle. I'm trying to reach 100.111/32 on both ISPs, VIOS 1, VIOS 2, right here. And this one is configured with 0 latency. And this one is considered with 200 latency. So this one is right now up. And this one is configured with 0 latency. And this one is configured with 200. And I'll show you how that is configured on VMware player. Okay. So latency here, your preferred route is this guy. This is your backup, failover backup, and this is how it's going to look like with a switch in the middle. Your links are configured like this. Primary is this one, has 0 latency, incoming, outgoing, and your backup is this guy, and it has 200 millisecond outgoing, right? So when it dynamically fails over, you'll see it switches to 200 milliseconds. Let's go and simulate this. Start the pings to, so you got the default route configured here, you can see it. And you can see that the arrow is pointing towards the lower admin distance 10, and it's not using the 101 right now. Okay, let's start the pings. It's going with 0 latency. Okay, now I'm gonna fail over this link. So I fail over this link like this with a switch. The way I do that would be I would go to this guy, BIOS1, and I would disconnect my link. And I would notice that since my switch is in the middle and this link did not go down, it's still up, my floating static is not going to work. Okay, it's just going to fail. And I have to wait until the link comes back up. So I bring the link back up. It's not failing over. And it starts working. Okay. Now let's take the switch out of the picture. And when I fail this link, I'm going to fail it from this side just to give you the simulation part. Again, in the real world, this is how it's going to work. But for the emulated part, I'm failing on 2 different sides just to emulate a switch in the middle. Hope you're following me. So I'm going through the primary link right now, right? Latency is 0, as you can see, 0. I'm going to fail the link, and it will dynamically fail over with a floating static. Moral of the story is don't use a switch if you don't have to. So I'm going to fail the primary link. Watch what happens. It fails and immediately goes to the 200 millisecond right there. Sounds good. Comes back up, and it's immediately going to fail back to switch back to the primary one. Watch, and immediately goes to 0 latency. So it's dynamically switching. It's dynamically failing over and choosing the preferred route based on the link state. Put a switch in the middle, it's not going to happen. That's what we did, right? That's what we just saw. So that basically tells you that if you don't have to, don't put this guy in. I am not a big fan of putting switches, unnecessarily switch links when you are going to be designing something like this. Now, the only consideration now would be that if this distance is far, use fiber instead of copper. And that will take care of the distance limitation. But if you want to keep your design simple, which I am a fan of, and don't want to get into, if obviously you're doing floating statics or default routes because you're not doing BGP routing with your ISP. So make sure you don't misunderstand me. This is only going to work, or should be used, when you do not use BGP with your ISP, right? BGP's use case is when you have public address spaces and you want to advertise them through 2 or more ISPs so that you can do some BGP load balancing using local preference for exiting traffic. And then you can use prepends, AS prepends for incoming traffic. But you gotta advertise those routes through BGP to your ISP. So I'm not discussing that. This is like a full route table download to your edge router, multiple edge routers, and doing a lot of advanced design. I've already got a video on local preference and prepend and how to influence exit and coming in traffic. Here we're discussing simple default route if you have a smaller design, and how not to use a switch in the middle so that when the link fails, you can dynamically fail over. Hope this helps.